Hi everyone, welcome back to my videos. I like to do a tutorial on inscribed and circumscribed polygons. Let's start off with some definitions. An inscribed polygon has all of its vertices on a circle. So if we look at this polygon ABCD, each vertex, point A, point B, point C, point D, is on the circle. So we say polygon ABCD is inscribed in a circle of center O, and O is called the circumcenter. A circumscribed polygon has each of its sides tangent to a circle. So let's look at this polygon EFGH. So each side is tangent to the circle at one point, right? So side EF is tangent to the circle here, and then so on. Polygon EFGH is circumscribed about a circle of center P. P is called an incenter. So let's go to our theorem. Given a circle center O, inscribed quadrilateral RSTU, angle S is supplementary to angle T, and angle R is supplementary to angle U. That's what we're going to prove. So let's write down what we know. Angle S is an inscribed angle. Its vertex at point S is on the circle, and its sides, segment SR and segment SU, are chords. Remember, a chord is a segment joining two distinct points in the circle. We can use the formula for measure of an inscribed angle to get measure of angle S equals 1/2 times measure of arc UTR. Angle T is also an inscribed angle. Its vertex is on the circle and its sides are chords. Measure of angle T equals 1/2 times the measure of arc RSU. Now, if we add the measure of arc UTR and the measure of arc RSU, we should get 360 degrees, right? Because it's going to be a full rotation of the circle. So we can add what we have in statement 4 and statement 6, and then use the property of equalities to get measure of angle S plus measure of angle T equals 1/2 times the measure of arc UTR plus the measure of arc RSU. If we substitute, we get measure of angle S plus measure of angle T equals 1/2 times 360 degrees equals 180 degrees. So that's just the definition of supplementary, right? Angle S is supplementary to angle T, means measure of angle S plus measure of angle T equals 180 degrees. I didn't do the proof for R is supplementary to angle U, but it's the same reasoning. You just change around the angles. That's actually a good exercise for you to do. Okay, so the next theorem. So we're given a circle center O, an inscribed parallelogram ABCD. Prove that ABCD is a rectangle. So write down what we know. And we know that angle A is congruent to angle D because opposite angles in a parallelogram are congruent. We also know that angle A is supplementary to angle D because opposite angles in an inscribed quadrilateral are supplementary. That was the last theorem we just showed. So we know angles that are both supplementary and congruent are right angles. So angle A and angle D are right angles. And a parallelogram with at least one right angle is a rectangle. So ABCD is a rectangle. Example 1, given a circle center P, an inscribed quadrilateral ABCD, measure of angle A equals 110 degrees, measure of angle B equals 80 degrees. Find the measure of angle C and find the measure of angle D. So I write down what we know, and angle A and angle D are opposite angles. So since opposite angles of an inscribed quadrilateral are supplementary, then measure of angle A plus measure of angle D equals 180 degrees. We can substitute measure of angle A equals 110 degrees to get measure of angle D equals 70 degrees. Angle B and angle C are opposite angles, so measure of angle B plus measure of angle C equals 180 degrees. And then you substitute measure of angle B equals 80 degrees into this equation in 7, and we get measure of angle C equals 100 degrees. So this is going to be the last problem we're going to do for this video. So we're given an inscribed trapezoid ABCD in a circle C, and we're given segment AB is parallel to segment CD. Prove that ABCD is an isosceles trapezoid. So I write down what we know, and I'm going to draw a segment BC. We can draw a segment between 2 points. Angle 1 is congruent to angle 2. So why is that? Because we know that segment AB is parallel to segment CD, and if we take BC as a transversal, then angle 1 and angle 2 are alternate interior angles, right? They're both on opposite sides of the transversal, and they're in the interior region bounded by, segment AB and segment CD. So we know angle 1 is congruent to angle 2. Measure of angle 1 equals measure of angle 2 by the definition of angle congruence. And we know opposite angles in an inscribed quadrilateral are supplementary. So measure of angle A plus measure of angle D equals 180 degrees. Measure of angle A equals 180 degrees minus measure of angle D. We know the sum of angle measures of a triangle is 180 degrees. So measure of angle A plus measure of angle 1 plus measure of angle 3 equals 180 degrees. We can do some algebra, get measure of angle A equals 180 minus measure of angle 1 minus measure of angle 3. We can substitute what we have in 6 to get measure of angle A equals 180 minus measure of angle 2 minus measure of angle 3. So I substitute measure of angle 2 for measure of angle 1, right? So now we can use the property of equalities to get what we have in 8 and what we have in 11. So we get 180 minus measure of angle D equals 180 minus measure of angle 2 minus measure of angle 3. So if I do some algebra, we can cancel out the 180 and then, rearrange this to get measure of angle D equals measure of angle 2 plus measure of angle 3. But we also know that measure of angle C is equal to measure of angle 2 plus measure of angle 3 by the angle addition postulate. So we can do property of equalities to get measure of angle D equals measure of angle C. And by the definition of angle congruence, angle D is congruent to angle C. Well, angle C and angle D are both lower base angles, right, in the trapezoid. So if those two lower base angles are congruent, then the trapezoid is isosceles. So ABCD is an isosceles trapezoid. So that's all I have for you in this video. It's pretty short, but please go over it. I thought this problem was pretty fun to solve, so it's an interesting problem. And I hope to see you during my next tutorials. All right, take care, everyone. Bye.